How does your body defend itself against infections? This video explores the body's first line of defense and the role of vaccination. Discover how these systems work together to protect you from diseases. Infections spread through 6 key stages known as the chain of infection. A harmful pathogen causes infection, multiplying in a conducive environment. Transport mechanisms allow the pathogen to move and enter the body. It exits the body and then enters another person's body. Understanding these stages helps in breaking the chain and preventing infections. The body's first line of defense includes various cells and systems. Red and white blood cells, along with platelets, play crucial roles. The immune system, including B cells and T cells, is vital. Vaccines introduce antigens to work with these cells. A prime example is the COVID-19 vaccine. The immune system is divided into innate and adaptive systems. The innate system includes skin, mucus, and cilia. The adaptive system involves B cells and T cells, creating antibodies. Vaccination introduces a harmless pathogen version to stimulate adaptive immunity. Memory cells ensure a quicker response to familiar pathogens. Nonspecific defenses include various barriers to infection. Skin acts as an impervious barrier, while mucous membranes trap pathogens. Stomach acid kills pathogens with its low pH. Vaginal secretions and urine provide acidic environments toxic to pathogens. Hairs, cilia, tears, sweat, and saliva possess antibacterial properties. The specific immune response is the body's targeted defense. White blood cells or leukocytes play a central role. Granulocytes and agranulocytes are types of leukocytes. Neutrophils, eosinophils, and basophils have distinct functions. Lymphocytes and monocytes are involved in specific immune responses. Leukocytes patrol the blood for infective organisms. Granulocytes, like neutrophils, engulf bacteria. Eosinophils target parasitic worms, while basophils prevent inflammation. Agranulocytes include lymphocytes and monocytes. These cells are crucial in the body's immune defense. Platelets primarily prevent and stop bleeding. They repair ruptured blood vessels and form clots. This process is vital at injury sites. Thrombosis is related to platelet function. Platelets play a crucial role in maintaining blood integrity. The body's third line of defense involves specific immune responses. Antigens are foreign substances triggering this response. The body recognizes non-self antigens, initiating a cascade of events. 2 responses are triggered: humoral and cell-mediated immunity. These responses are crucial for targeted pathogen defense. Humoral immunity involves B cells recognizing circulating antigens. Memory cells ensure rapid future responses. Cell-mediated immunity involves T cells recognizing altered cells. Helper T cells stimulate B cells for antibody production. Cell-mediated immunity is crucial against cancers and viruses. Vaccination produces active immunity without disease development. A strict vaccination schedule protects children and communities. Vaccines introduce antigens and can be live attenuated or inactivated. Examples include measles, mumps, rubella, polio, and influenza. Vaccination is a critical tool in disease prevention. Humoral immunity involves B cells and antibody production. Memory cells ensure quick antigen recognition. This process is known as natural or acquired immunity. T cells recognize altered cells and produce helper T cells. These stimulate B cells for antibody production, crucial for immune defense. Correct. Cell-mediated immunity does not involve antibodies. T cells recognize altered cells, such as those affected by tumors or viruses. Helper T cells stimulate B cells for antibody production. This is the body's first reaction to cancers and viruses. Cell-mediated immunity is crucial for targeted defense. The antigen-antibody complex is central to immune response. Macrophages present antigens to lymphocytes. T cells divide into clones with specific roles. Helper, cytotoxic, memory, and suppressor T cells have distinct functions. B cells produce antibodies, forming the antigen-antibody complex. Non-self antigens enter and multiply in the body. They circulate via blood and lymph. B cells activate in the lymphatic system. Macrophages present the virus to T cells, activating them. T cells divide into clones with specific roles. T cells have specific roles in immune response. Killer T cells destroy antigens at infection sites. Helper T cells promote macrophage phagocytosis. Memory T cells remember antigens for future encounters. Suppressor T cells end the immune response when necessary. Antibodies neutralize viruses, preventing attachment and toxin production. Agglutination clumps virus particles together. Precipitation makes foreign antigens insoluble for destruction. Complement fixation labels foreign cells for phagocytosis. These mechanisms are part of the natural immune system. Artificial immunity enhances the natural immune system. Vaccinations are the most common method. They introduce antigens to stimulate immune response. This prepares the body for future encounters with pathogens. Vaccination is crucial for preventing infectious diseases. The skin acts as a physical barrier against pathogens. Tears contain enzymes, providing a chemical barrier. The nose has hairs and mucus to trap pathogens. Stomach acid kills pathogens caught in mucus. These systems form the body's nonspecific defense. The trachea is lined with ciliated cells. These cells move mucus and pathogens upwards. Goblet cells create mucus to trap pathogens. This forms a physical barrier in the airways. Ciliated cells reduce pathogens entering the lungs. Stay informed and protected against infectious diseases.